Hello and welcome to another fun-filled day in math with Mr. Sims. It's been a lot of fun today. We've been practicing new stuff. And one of the cool new things I want to do with you is work through some linear regression practice. And I'm actually going to do all this. Normally I would take my pen out and I'd actually draw some stuff, but all of this stuff is really done on the calculator. And since it's all done on the calculator, what I'm going to do is I'm basically going to do a few of the problems here with you. That way you can do it in your calculator and then move over to here and do it. Alright? So once again, all I've done is I went to Google Classroom and I pulled up your assignment, which was the linear regression practice. Okay, so I went and I clicked that on Google Classroom. The link brought me here. One sec, I have to go murder my dog. Not that I'd actually murder a dog, because I really like dogs and they're cute, but he's very annoying right now. Alright, dog, out of the house. Out of the house, buddy. You see, my wife and I, we thought that we were big dog people, but then we had a big dog, and now we realized we're not big dog people. But anyway, moving on. So, on to the math. What we're going to do is do some linear regression practice here. So, I have my question 1, which is, this is my x and the y's for question number 1. And what I'm going to do is... Oh, okay. So yeah, this question 1, it says, basically, this is the data they give you, and they said, in the line of best fit, what is the slope? Round to the nearest tenth if necessary. In the line of best fit, what's the y-intercept? Round to the nearest tenth if necessary. What is the full equation for the line of best fit? Round to the nearest tenth if necessary. What is the correlation coefficient? Round to the nearest hundredth if necessary. What type of correlation does the graph have? And find y when x is 3. All right, so all of these questions, all of these things here can be solved via the new trick that we taught you on your Cycle 21 notes from yesterday, which you should be reading these, even though these aren't technically assignments at this point, because we're probably not going to be able to take them up. You should be reading those and keeping up with them, because that's all the new material is based on what we're learning, the new stuff we're learning. So get your cool learning on and do it. All right, moving on. Here we go. So for this one here, the first thing I have to do is I have to get my calculator ready and get it into the place where it can do the stuff that I need it to do. So what I'm going to do is I'm going to start by always clearing my calculator, second plus 712. And this is my calculator here. It's just like your calculator. If you haven't gotten the emulator software, look through the Google Classroom to find the link to get the emulator software, this software here that I'm using, so that you can do all the work that you need to do in case you don't have a calculator. If you do have a calculator, you're pressing the same buttons. This is exactly what your calculator basically looks like, okay? So anyway, I did second plus 712. You can see it down here is the key press history in case you miss what I'm doing. And so second plus 712 is the first step. Then the next step is, let me see, enter. I'm going to go to, I got to turn on 2 different things. So the first thing I'm going to do is I'm going to go to mode here, and when I get to mode, I want to go down here to this stat diagnostic, and I want to turn it on. So I'm actually going to go up just because it's a little bit faster. I could have gotten into there by going down too, okay? But anyway, the whole point is you want to get to where stat diagnostics is at, and you want to move over to the right and turn it on, and then you want to hit enter, okay? Now when I'm done with that, I could quit out of there, second quit, or the other thing I could just do is just go to my next thing that I need to do. So the first thing I need to do, once again, turn on stat diagnostic. The second thing I need to do is I'm going to go second y equals, and this plot 1 here, I need to hit enter, and then you see it went to on or off here, and then I'm going to hit enter for on, and then I'm going to hit second quit to get out of there. Okay, so once again, there's 2 steps. Second plus 712, resetting it, and then you went to your mode and you went turn stat diagnostic on. And then the other thing you did was you turn on your second y equals, you went to stat plot and you turn on your stat plot. And both of those are necessary. The stat diagnostic, what that's going to tell it to do is it's going to tell it to take statistical data, like take your whatever data you put in, and it can run actually statistical values for it. Particularly, it's going to let you run the correlation coefficient, which you need in order to know how well the graph correlates and how well a line of best fit fits it. Okay. So anyway, without further ado, we now are ready to put in these points here. So I'm going to go to Stat, Edit. I'm going to hit Enter. Okay. So when I did that, now I hit Stat. I went to Stat Edit, and I'm going to put in all the X values in this L1 and all the Y values in this L2, and they have to match up. So if I put 2 here, I got to put 14 here. 8 here, I have to put 32 here. They have to match up like they're supposed to, okay? So I'm going to start with 2, enter, 8, enter, -5. Don't forget to use this negative. This is a minus sign, not a negative according to your calculator. It views them differently. So please make sure you do -5, otherwise it's going to give you an error, okay? And then I'm going to move over to this next section here. I'm going to put in 14. I'm going to put in 32. I'm going to put in -7, and finally -10. And when I do that, I now have all my data. It matches all the data that I have over here, okay? And having that data in, basically I've given the thing a lot of XY points. And what I'm going to do now is I'm going to actually calculate the line of best fit based on that. It's called doing a linear regression, okay? So I'm going to hit Stat, then I'm going to go to Calc, and then I'm going to go down all the way to linear regression here, which is number 4. So I hit Enter. And I'm actually going to go back out to there really quickly. You don't have to do this, but I'm just going to do it. I want to show you there's a lot of different regressions here. There's a linear regression, which is making a line, basically a line of best fit. There's a quadratic regression, which would be, let's say we think our data is more of a quadratic shape, then we could make a quadratic that best fits it, right? A cubic regression, which looks something like this, by the way. And if it's a cubic regression, it's going to follow a line of best fit that might look like something like that, right? So different data might have different regressions that fit it, okay? So based on that, like later on, if you go all the way down here, there's exponential regression, which we're going to use this year as well. But I just want you to see there's lots of different regressions. And basically, this linear regression is basically saying we want a line of best fit, not a quadratic of best fit, not a cubic of best fit. We want a line of best fit. So that's why we're going to number 4, and we're doing that line of best fit, right? And I'm going to go down here. This is just a good habit to get in, right? You want to go to store your regression equation. Technically, for a lot of these, actually, it's not going to be necessary, but the nice thing about storing the regression equation, you can actually see your line, okay? So the way you want to do this is to store your regression equation. You want to hit vars, then you want to go to yvars, you want to hit enter for function, and y1 you hit enter. And what that's telling it to do is, hey, whenever you figure out what that line of best fit is, I want you to store it in y1. And when you do that, it should make it in y1. We'll see it in just a second here, okay? And then I'm going to hit enter and enter to calculate. And congratulations, I have a beautiful all my beautiful information here. Now you'll see it says y is equal to ax plus b. We use mx plus b, but it's the same thing. It's basically saying that a is the slope, okay? So your slope is 3, and your y-intercept is 8. So I'm going to go back over here to my thing. In the line of best fit, what is the slope? The slope is 3, right? I wonder what happens if I type it in wrong. Did it even let me? Oh. No, I think I'm just going to get it wrong. I don't want to get it wrong. So I'm going to put in 3. What's the y-intercept? The y-intercept is 8, right? What is the full equation for the line of best fit then? Is going to be y is equal to mx plus b, right? mx plus b, or in this case a, right? Ax plus b. So it's going to be 3x plus the b, which is 8. And that's my equation of the line in slope-intercept form. What is the correlation coefficient? Now the correlation coefficient is this one here. R is equal to 1. It's whatever R is equal to. So R is equal to 1. And what that means is that it's a perfect correlation. In other words, all of your lines, the line of best fit that it made went perfectly through every single point that you gave it. All right? And actually, if we wanted to see that right here, I could look at it, and you can see if I go to zoom fit, so all the points fit on there as well. If I go to zoom fit, enter, right? You can see it literally went through every single point that I gave it, okay? So that's why it has a statistical correlation of 1. The reason why it's positive 1 and not negative 1 is that slope is it's a positive slope. So that correlation coefficient is telling me that that this line of best fit perfectly fits those points, all right, in a positive fashion, that those points have a positive relationship, that as I go up in x, y also goes up. Okay, so what type of correlation does the graph have then? This would be what we call a strong positive correlation, okay, because it's a positive slope and it's strong because it basically fits a perfect line, okay. Well, the closer it is to fitting a perfect line, the more of a strong correlation it is. And this is actually a perfect positive correlation. It's actually a perfectly strong positive correlation. Find y when x is 3. So to find y when x is 3, I'm going to hit trace, right? And I'm just going to type in, here's x equals 2, y equals 14. Rather, I could just move along the line if I want, right? But I want to make sure I get the perfect exact data. So actually, I'm actually not on the line. Right now, I'm on the points. You can tell because it says plot 1, L1, L2. I don't want to be on the points. I want to be on the line. So I'm going to hit down, and it's going to jump to the line. The reason I know it jumps to the line is because it says y1 is equal to 3x plus 8. And so what I want to do now is I could move up and down and kind of figure out about where 3 is at, right? Or the other thing I do is just hit enter 3. If I type in 3, it's going to make my x value 3, and it's going to tell me what my y value is. My y value is 17. So find y when x is 3. The answer is 17, right? How cool is that? You know it's cool. I know it is too. All right. So, did I do that right? I think I did it right. Yeah, right. Yeah, I'm good. All right, so 17. Okay. Question 2. So once again, same thing, right? They gave us data, and then they want to know the slope, and they want to know the y-intercept, and they want to know the full equation and the correlation coefficient and what type of correlation the graph has, and find y when x is 17. So basically the same thing, okay? So once again, I'm going to go to stat, edit, right? I'm actually going to start from the very beginning. Second plus 7, 1, 2, all right? I'm just going to assume that you're starting from the beginning. You want to run through the whole steps, all the steps. I suggest you run through them all again and again and again, because frankly, it's going to take like 20 times for you to remember it at least, right? So if you do that, you're going to just be better off, right? So second plus 712 to reset it. Then remember, I'm going to turn on, no, I'm sorry, I'm going to go to my mode, and I'm going to turn on my stat diagnostics, right? And then I'm going to go to second y equals and turn on my stat plot. Enter, enter, and then I can quit out of that. Now I'm going to hit stat, edit, right? And I'm going to put in the data points that they gave me. So the data points they gave me were 11. Oh, sorry. Where's my points? There we go. 11.8, right? Enter. 14 point. Whoa, that didn't work. Let me try that again. 14.2. Enter. 15.3. Enter. 16.3. Enter. 18.5. Enter. Okay, so I got all of those on the left hand side. I'm going to go to the next one. 195, enter. 210, enter. 370, enter. 330, enter. And finally 400, enter. And now that I have all of my points in there, I'm going to now calculate with that. So I'm going to hit stat calc. And I want to do a linear regression because that's the only ones we've taught you so far, right? But even like I said before, there's lots of different regressions we could do. Later on in the year, we'll do exponential regression. But right now, let's do linear regression. I'm going to hit enter. And I want to go down and store my whatever equation, whatever line of best fit it gives me, I want to store it as into y1 so I can see it, okay? So I went to, once again, I went to vars, to the y variables, the variables and then the functions, y1 here, and I'm going to hit enter. Awesome. So I stored my regression equation now in y1. Well, all these steps, by the way, are in your calculator, not in calculator, in your notes in case you want to review and make sure you got it, okay? So anyway, then I'm going to hit enter. And this one's not as pretty as the last one, okay? And In fact, I'm going to answer the questions, but then I'm going to show you the graph so you can see why it's not as pretty as the other one. So once again, y is equal to ax plus b. This a is my slope, right? It's the one attached to the x. So a is 33.115. They want us to round to the nearest tenth. So remember, this is your tenths place, your hundredths place. So they want me to round to this place here. So I go to this place. I look to the right. Number is not 5. It's less than 5, so this number is going to stay the same. So this is 33.1, right? Is my line, my slope for my line of best fit. The next one is b. b is equal to negative 203 point. I'm going to round to the nearest tenth as well. This is once again my tenths place, so I look to this one. This one's not at least 5, so this means this one's going to stay as 0. So it's going to be negative 203.0, right? Or just negative 203 would also work. What is the full equation for the line of best fit here? Is going to be y is equal to 33.1 x minus 203.0, right? And I basically, what I've done is I've just put in the data like I had it, right? Once again, I have my slope and my y-intercept, okay? And then they want to know what's the correlation coefficient. Now you look at this correlation coefficient. By the way, don't worry about this r squared. There's a reason there for the r squared, but it's not anything that we're going to worry about this year. So you can look at that and figure it out if you want to know what r squared is all about. But for now, we're going to focus on r. All right. So your R value in this case, they went around to the nearest hundredths place. So this is your tenths place, this is your hundredths place. So it's going to be 0.88, right? Or 0.88 would also work. That's the correlation coefficient rounded to the nearest hundredths, right? Once again, I look to the right of it, it's a 0, so that one stays the same. And then finally, what type of correlation does the graph have? Well, as you can see, that's a positive number. That tells me it's going to be a positive correlation, right? And that number is greater than 0.5. So if it's greater than 0.5, we can say it's got a strong positive correlation, okay? So we have a strong positive correlation because it's greater than 0.5, it's positive, so it's strong positive, okay? Find y when x is 17, round to the nearest tenth. So the y value when x is 17, to get there, I have to graph it, right? So I'm going to go ahead and graph that now. I can't see that at all, so I'm going to go to zoom fit. What on earth was that? So I'm going to go to zoom fit, enter. And why did that not work? Zoom fit, enter. Mode, did I turn on? I know I turned on my stat diagnostics. Did I remember to turn on my stat plot? I did. So why are my points not there? StatsCalc, let's see. Enter. Yeah. Hold on a sec. Let me see what happened. I'm going to zoom way out. Okay, they're there. For some reason, I thought when you hit zoom fit, I thought it made sure your points were in there. Oh, maybe it was zoom stat. I think that's the one I'm looking. Yeah, that's the one I'm looking for. Okay, so basically, now you can see that this line, it does not fit the points as well as the other one did, right? But it is still a pretty good fit for the line. But as you can see, the points are also pretty scattered about. If you wanted to kind of see them a little bit further out, you could zoom out, right? And you can see how, although they're close to a line, right, they're not as close as the other one was. The other one was a perfect line, right? So it is a strong positive correlation, but it's not, at 0.88, it's not as good as the 1.0 we had before, right? But to find y when x is 17, right, I'm going to hit trace. And right now I'm tracing L1 and L2. So I'm tracing the points, right? So if I go and I move to the right, it's moving right on those points. If I move to the left, it's moving left on those points. I don't want that. I want it to move on the line. So I'm going to go to my line here. I press down to jump to the line. So now that I'm on the line, I can move up and down on the line. And I want to get to what? Find y when x is 17. So I could go until x is what? X is 17, right? I could keep doing that, right? 17. But see, you're going to see it doesn't actually land on 17 perfectly, does it? So because it doesn't, the way you handle that is you just hit you just start typing 17. And when you start typing 17 into your calculator, it'll tell the calculator, "Hey, I want to know when x is 17." So when you do that, now it brings it directly to when x is 17, and it tells me my y value is 359.94, so on and so forth. They want me to round once again to the nearest tenth. So if I'm looking at my tenths place, this is the 9 here, right? If I look to the right of that 9, I have a 4 there. Well, that 4 is not at least 5. It has to be at least 5 to make this number change. So this is just going to stay 359.9. Now I know some of you are thinking, Mr. Sens, we know how to round, but some of the things I've seen tells me some people have not figured it out yet. So I'm just making sure. All right, so if I am acting like you don't know how to do it, it's because I'm concerned for some people, okay? So here we go. Moving on. Next. All right. I'm going to do one more example. Let's see here. How many of these are there? You know what? I'm just going to type in random data. This is not right. None of this is right here, okay? But I want to see if any of these other problems have different information, okay, that you're required for. Okay. So I'm going to do one more. Like I said, I'm just typing in random numbers just to get further along in the process, okay? So, okay, let's see. Okay, let's do this last one. This will be my last one I'll do with you, okay? But it'll give you some help to get started. So here we go. I'm going to once again start off with second plus 712. I always do that because I don't know who had it before me. I don't know what might happen, and so I'm just going to go ahead and clear it out. And then I have to turn on two things. First thing I got to turn on is my stat diagnostic. So I go to mode, go up to stat diagnostic, move to on, and hit enter. Then I go second, y equals, and then the stat plot 1, I hit enter, and then it's already on, so I hit enter, right? And now I can hit second quit to get out of there. Well, now that I have that, I'm going to go to stat edit, which is the first one that's on, so I hit enter, and I'm going to put in all these points here. So I got to get -2, -1. I'm going to show you what happens if you accidentally put in -2. So here's what I'm going to do. I'm going to delete that. Here we go. So let's say I accidentally type in -2. If I hit enter, it's going to give me this error here. And that's, if you get something like that, check to make sure that you put the negative and not the minus sign, okay? That's a common mistake I see students making. So once again, stat, edit, -2, enter, -1, enter, 0, enter, 1, enter, 2, enter, and next side. I get -45, enter, -33, enter, -21, enter, -9, and so forth, and 3. Alright, so now that I have all of those there, they're in. That's a good sign. I'm going to hit stat, and I'm going to go to calc, and I want to calculate, once again, a linear regression, alright? All problems can be solved using a linear regression. Later on, you're going to have to figure out which one it is. In this case, it is the linear regression, though, so we're going to go down to 4, which is my linear regression. In other words, I'm making my line of best fit. So I'm going to store in my regression equation by hitting vars. Then I'm going to go over to yvars, and I'm going to go to my function, which is enter, y1, and that tells me, once again, it tells the calculator, I want to store whatever you come up with as my line of best fit. I want it stored in y1. All right? If you want, one of the things you can do just for kicks and grins is if you want to see where data like this is actually applicable a little bit, you could actually make an exponential regression for the coronavirus. Like if you wanted to, it's fairly growing on a kind of fairly exponential curve. It's actually not an exponential curve. It's called a logistical curve, I think is what it's called, if I recall correctly. But you need to run a logistical regression is what I mean to say. And what that is that's a exponential. It starts out exponential, but then it reaches the carrying capacity, and so it kind of peters off a little bit. And so anyway, that'd be actually closer to what this actually follows model wise. But anyway, I'm geeking out math-wise here. So all that to say, if you wanted to see it, kind of have an idea though of at least the initial onset of what it might look like in a certain country, in our country, for instance, you can actually do that just to kind of see the math behind it. Because basically, that's you guys are always asking when is math useful, and basically all these mathematical projections that they're having at this time are all based on math, like all these coronavirus projections of what it's going to look like, when it's going to peak and stuff. This all based on actual mathematical models. So very, very cool when you use math like all the time. So okay, moving on. Story regression equation. I'll get off my soapbox. All right, story regression equation y1. We're done, and I'm going to hit calculate, and boom goes the dynamite. This right here is my equation. It's my linear regression equation. As you can see, it's got ax plus b. Right. This is 12. My slope is 12 once again, right? What is the y-intercept? The y-intercept is negative 21, right? What's the full equation for the line of best fit? It's going to be y is equal to that 12x, right, minus 21. And what is the correlation coefficient? The correlation coefficient here is 1. So my correlation coefficient is 1. And that tells me once again that this is a perfectly positive correlation. I should expect that my line will go through every single point that I have. When I'm looking at the graph, I should see that. So what type of correlation is this? This is a strong positive correlation. In fact, it's the most strong positive correlation that I can have with an R value of 1. Finally, find f of negative 11.4. So to find f of negative 11.4, I'm going to go to graph, right? Here's my thing. I'm going to go to zoom. I like to see it with everything. So I'm going to go down to zoom stat because I want to see all of the points that I plotted. And as you can see, these are all the 5 points that I had in my chart, right? And I wanted to draw that line of best fit, and that line of best fit is a perfect match, which is what we should expect because we had a correlation value of 1. So that means it literally goes through every single point perfectly. And now I want to find f of negative 11.4. So I'm going to actually hit trace. And as you can see right now, it's tracing the dots. I don't want to trace the dots. I want to trace the line. So I'm going to hit the down arrow to get to the line, to jump to the line. Now that it's jumped to the line, I want to go to negative 11.4. And the easiest way is not on my graph. So I'm going to zoom out. And I'm going to zoom out there. And now I should be able to go to 11. Oh, trace. Go back down the line. I should go down to negative 11.4. All right, so somewhere around here. Now once again, it's not going to land perfectly on it, so the way I handle that is I just start typing in negative 11.4. Oop, but I actually don't want this negative. I want, oh, what did I do? Trace, here we go. So I want to hit negative 11.4, okay? What the, no, graph, trace, down, negative 11.4. There we go. All right, so I hit the negative 11.4, and as you can see, the y value then is going to be negative 157.8. Okay, and I'm going to hit next. All right, so I'm going to hit second plus 712 just to clear it out. Okay. So write the slope-intercept form of the equation of the line through these 2 points. So basically, you're going to do the same thing you did, right? But you're only having 2 points to use, okay? So I'm going to let you actually do that, right? And you're going to round to the nearest tenth if necessary. Okay, so I'm going to let you go ahead and do that because I think you got it, right? I'm going to move on to the next one. I'm going to say y is equal to 3x plus 4, whatever. That's not right. That's completely horrendously wrong. But I just did that you know what, I'm just going to do that. Let me do another one. Let me see if it changes. All right, I could do one of these here. So let me do this one here. So I got write the slope-intercept form. So hopefully you've been doing these as we've been doing them, right? So I hit second plus 712 to reset my calculator, right? I'm going to hit mode. I'm going to go to stat diagnostics, right? and my stat diagnostic, I'm going to turn to on. I hit enter. Then I'm going to hit second y equals, and I have plot 1. My plot 1 is, what am I doing? Plot 1 is on. I'm going to turn it on, right? Then I hit second quit to get out of that, and I'm going to hit stat edit. These, you should get really, really, really comfortable with those things. I'm going to actually clear all this here. So I'm going to hit -4 and 1, okay? And I'm going to hit 2 and -5, okay? Alright, so now that I have my points in there, right? Basically, my x's and my y values, right? Now I'm going to do StatsCalc. Going to go down to linear regression, right? Going to go down to store my regression in yvars. I'm going to go function y1. It's actually not even necessary for this problem, but I just like to get in the habit of doing it. It's a nice thing to have in case I want to look at the data later. And this one here, as you can see, let me just point out a couple pieces of the data. So this is my slope, this is my y-intercept, this is my correlation coefficient. This is a perfectly negative correlation. It means that this line completely fits these 2 points that I gave it, or the 2 points I gave it earlier. That the line that best fitted it came up with perfectly went through those two. So based on that, oh, sorry, pardon me. So I'm going to type in y is equal to -1.4 x minus 3.6, and that's my answer. Okay, I'm going to submit that. I'm going to view my score. Let's see how I did. Class period 1, question 1, it looks like I knocked that one out of the park. Question 2, it looks like I knocked that one out of the park. Question 3, I guessed and did not knock it out of the park. Hey, I did get one part right though. Question 4, I also guessed and did not knock it out of the park. Question 5, I got it right. It feels good. And questions, all of these I got wrong because I guessed. Then finally I did the last one there for you, okay? So once again, hopefully you were able to follow along with that, right? If you need to, where you watch the video, you need to do those steps over and over, which is one of the reasons why we have all this practice here for you, right? You need to do the steps over and over and over, otherwise it won't stick. The good news, though, for you is this trick that you just learned, you can literally use that to find slope like we've been doing all year long. Anytime you get points like that, you can find the slope super fast just by typing in those points, right? So now that you know that trick, you can use it for that if you want, right? If we were to ask you the y-intercept of a line, you could find that. So basically, it helps you find the equation of the line super fast, whereas before you had to go through all those steps. This way you could do it in the calculator. Now, should you still remember how to go through all the steps? Absolutely. That's the better way to do it. That's the way to show your work and everything. But I'm just showing you that if you ever wanted, like, to say check your answer, or let's say you're on a timed test and you need to go quickly, then that might be some option for you. But especially if you're checking your work, okay? All right, I wish you the very, very, very best. You guys are truly amazing. Thanks for watching, and I hope this was helpful. And I will talk to you soon.